Today we're talking about even functions. And as always, we look through the lens of the rule of four, which is every function can be described using a written description, a table of values, a graph, and an equation. So first we're going to look at what an even function is. An even function has reflectional symmetry across the y-axis. Now, visually, when we think about that, that might mean it looks like a parabola, like that. Or it might be sort of more interesting, like maybe it goes like, ooh, like that. Or, I don't know, maybe it goes like, it's just a big old frowny face. It doesn't necessarily have to point up. But whatever it is, it's going to have the same thing happening over here as it will over here. Something like that. Let's look at our old friend, the parabola. Shoop. All right. Now, if we think about our table of values, we'll have an x and a y, or an x and an f of x. And we will have the point, like one of the points on there is 1, 1. Notice we also have this sort of corresponding point. We go over 1, up 1. We also have this corresponding point over 1, back 1, up 1. So we also have negative 1, 1. We have 2, 4, and its sort of corresponding point, negative 2, negative 4. I'm sorry, positive 4. We would also have 3, 9, and negative 3, 9 as we went up. And so, maybe you start to notice that there's kind of like a pairing between these numbers, right? And so if I were to ask you, if I plug in 1, I get 1. If I plug in negative 1, I also get 1. I get the same answer. If I plug in 2, I get 4. But if I plug in negative 2, I also get 4. And so when we think about this, we can kind of think about when I plug in x, I get f of x. Sure, obviously, f of x is equal to f of x, duh. But when I plug in the opposite of x, I also get f of x. And this leads us to our definition of what an even function is. So if we think about it as a written description, it has reflectional symmetry across the y-axis. When we look at it as a picture of the function, when we look at it as a graph, we can see that reflectional symmetry, right? It's just as if you were to fold it over. What that means for us in the table is that if an input, like for example, 2, if an input 2 has an output of 4, 2, 4, we're going to also see negative 2 when we go back to also having an output of 4. And to generalize that, if I were to plug in the opposite of x into the function, if I were to find f of the opposite of x, I will get back the same number as if I were to plug in x. F of the opposite of x is equal to f of x. And that, my dear students, is the definition for what it means to be an even function.